Yes, my beautiful people, Banabaskolo, I hope that you are all ready. I hope that you're good. Today's show is going to be quite packed. There's a lot that we have in store for you. And again, like I said, even on our Edbook page, learning is fundamental. And just a quick brief of what you can expect on this show. I'll speak to Melo about mentors and mentees. So in case you were thinking, asking yourself, what is a mentor, what is a mentee?
And their duties.
Yeah,
all those things.
if I want to be a mentor, what should I do? What qualities should I have? If I want to be a mentee, how do I go about finding a mentor?
Yeah.
And so on. And on top of that, there are some very nice, handsome bursaries that are available. The applications are still open. We will be talking about that in a short while as well. And yeah, yes, at Bookworms, my fellow listeners by the Radioactive Hour, don't forget that we have our WhatsApp helpline. And you can get us on 060-949-7579. That is 060-949-7579. Just inbox us your questions, comments, or queries, or whatever on our WhatsApp page, and we will attend to that. And don't forget that you can also call us in studio if you have any query as well or any comments. That's 012-799-9257. That's 012-799-7257. But for now, let us carry on with the business of the day. On your worksheet that was posted on our Facebook page, today let's sort of just 2 pages of our worksheet. And like I said, we will be talking stoichiometry, that is calculations regarding chemicals, chemical reactions. Okay, so important concepts that you should remember. The mole. When we talk about the mole is a counting number. Now, what is a counting number? Think about when I talk about a pair or a dozen. When I'm talking about a pair, I'm talking about 2. When I'm talking about a dozen, I'm talking about 12. Yabo? Similarly, the number of particles in a mole, because when you talk mostly about moles, particles. Particles can either be our atoms, our electrons, or our molecules. Now, the number of particles in a mole is equivalent to 6.022 times 10 to the 23. That is a very large number. That's why we are in scientific notation, because it's a very huge number. That's millions and billions and yeah. So similarly, when you think mole, just think 6.022 times 10 to the 23 particles within that mole. Just like a pair, you start thinking of 2 things that make up that pair. Yeah. And then you know that the number of moles, we can find that by just taking the ratio of your mass to your molar mass. Yeah, that is the famous equation that you know is N is equal to M over M, capital M. And you know with your capital M, which is your molar mass, we find that by summing up your atomic weights. Now, how do you find your atomic weights? It's there on your periodic table, and it's also given at the back of your exam paper. As well, you can rearrange the formula. Now you can rearrange this N is equal to small m over capital M to either find the molar mass or the mass or whatever it is that you're looking for. Yeah, and then the concentration of a substance is basically the number of moles per given unit of volume. And you can easily find your concentration just by taking the ratio of your number of moles of substance to the volume of your solution. And your famous formula for this part is C is equal to N over M. And similarly, you can just rearrange all this to either find the number of moles or the volume or however you want it. And another important aspect is to recall that 1 mole of gas, we have 1 mole of gas at standard temperature and pressure. Now, when we talk about standard temperature and pressure, we talk of the temperature that is equal to 273 Kelvin. The pressure is usually, or rather not usually, is 101.3 kilopascals. And at that standard temperature and pressure, 1 mole of gas will occupy 22.4 decimeter cubed. Decimeter cubed, it's also the same as liters. So 1 decimeter cubed is equivalent to 1 liter. Now, these concepts, what I put on your worksheet, it's just a skeleton of some bits and pieces of the stuff that I find from various textbooks, various study guides, and here is a skeleton just to help you recall some of the stuff and your side notes and all that. Okay, so for now, I would like to begin with our warm-up question for today. It's a very nice, handsome one. Okay, part B, number 1. Part B. Okay, the concentration of a 150 centimeter cubed solution containing 5 grams of sodium chloride is, so this is a multiple choice question, and they gave you 4 options. Okay, now when they give you such a question, already you can see that it requires calculations. Now, if you know your stoichiometry, there's no reason you're during an exam or where my pen lands. This is it. This is how we go about it. Let's do the calculations. What is it that we are given? Well, we are given the volume of a solution, and we are given the mass of the substance in solution. And what we need to find is the concentration. How do we go about that? Well, you know from C is equals to N over V, we already have the volume. What we require is the number of moles of sodium chloride.
Repeat the question also first before you proceed. The question that was...
The question, okay. The question states, and I'm assuming you have your worksheets with you that you got from our website, the concentration of a 150 centimeter cubed solution containing 5 grams of sodium chloride is A, 0.9 moles per decimeter cubed, B, 5.7 times 10 to the minus 4 moles per decimeter cubed, C, 0.57 moles per decimeter cubed, or D, 0.3 moles per decimeter cubed. Now, they gave you all your options from A to D, and what you need to do now is to calculate, given your given variables above, in order to find your concentration. Now, remember, like I said, in order to find concentration, you need to have your number of moles and your volume. You already have your volume. What you need to do is to find your number of moles, and then you'll be well on your way. So how do we find our number of moles? Well, remember that the number of moles is given by your mass divided by your molar mass, okay? Now here you are given the mass of your substance, okay? You're given the mass of sodium chloride, which is 5 grams, okay? So like I said, your molar mass, you'll always find it on your periodic table. If you check on your periodic table, you can add up the atomic weights of sodium and chlorine, and they will add up. You'll have 23 plus 35.45, and then you can proceed with your calculations. That's 5 divided by 23 plus 35.45, and you will get 0.8554 and a very long decimal number. However, do not round off this number because you have not yet arrived at your final answer. What you should do at this moment in time is, I know that you also have fancy calculators, okay? Because this 0.855, that is your number of moles of sodium chloride. So what you should do now, you know that once you have your number of moles, you can divide it by the volume you are given, and then you have your concentration. Okay? So don't round off that number yet. Do not round it off. What you should do is take that very long decimal number, 0.85543199932, and as it goes, divide it by your volume, because now, at this point now, recall, we are calculating for concentration. So your concentration will be equal to your number of moles, which is 0.855, that long decimal number, divided by, now look over here. If you take a look on your worksheet, if you look at that question again, they say the concentration of a 150 centimeter cubed solution. Now recall that your SI unit for volume is decimeter cubed. Even if you look at your potential answers, they are in moles per decimeter cubed, which means that you have to convert from centimeter cubed to decimeter cubed. Now, how do we do that? You know that we divide by a factor of 1,000, okay? So you can take your volume that you're given, 150 centimeter cubes, and then you divide it by 1,000, or you multiply by 10 to the minus 3. So you plug that into your formula, and once you compute that, you'll find that now your concentration is 0.57 moles per decimeter cubed. Now, which one does it correspond to? Does it correspond to A, B, C, or D? Let's take a look at the potential answers again. It's A is 0.09 moles per decimeter cubed. B, 5.7 times 10 to the minus 4 moles per decimeter cubed. C, 0.5 moles per decimeter cubed. Or D, 0.3 moles per decimeter cubed. Now from that we can already see that yes, our answer is C. Yeah. So for me this is a very, 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 very nice question. It helps you to go from calculating the number of moles given your mass to finding the concentration of solution. Now from here onwards we will be browsing through, going through a typical exam question. Now this question is from the 2012 paper 2 exemplar, Yama grade 10. I took it was question 8, and let's see what it says. The reaction between magnesium and dilute hydrochloric acid is represented by the balanced chemical equation below. That is 1 magnesium reacting with 2 hydrochloric acids. It will give you 1 mole of magnesium chloride as well as 1 mole of hydrogen gas. The case study further says, during an experiment, 1.5 grams of magnesium reacts with excess dilute hydrochloric acid to produce hydrogen gas at STP, that is your standard temperature and pressure. Now, one important thing that you have to look at, they tell you that the magnesium reacts with excess dilute hydrochloric acid. Now, when a chemical component is in excess, it means it is in abundance. So the other reactant that is not in excess will be our limiting reagent. This means our products will be determined by the limiting reagent. The other one that is in excess, because even when the reaction has stopped, it will still be there. So it doesn't really have any much of a factor. Yes. So the first question, 8.11, they are asking us to calculate the mass of the hydrogen gas produced. Now, how do we go about finding the mass of the hydrogen gas? Well, we know that magnesium is our limiting reagent. So if magnesium is our limiting reagent, it means it will be used up. There won't be anything left. So if there's nothing left there, it means whatever amount of magnesium that is used will affect the amount of the products that is formed. Okay, so we only have the molar mass for hydrogen gas because we can easily get that from the periodic table. What we need now is to find the number of moles of hydrogen gas. Now, how do we find the number of moles? We are not given anything, hydrogen. However, we are given the mass of magnesium. Golden. So how do we move from the mass of magnesium to finding the number of moles of hydrogen? Look over here. We go back to looking at our balanced chemical equation. That is why, Banaba School, it is very, very, very important that you learn how to balance your chemical equations. Because sometimes they are going to leave it unbalanced and then about all balance. And I tell you, if you fail to balance your chemical equation, then you're going to have a tough time going forward. Now, let's see what information we can get from our balanced equation. Well, from our balanced equation, we can see that 1 magnesium will give us 1 hydrogen, meaning 1 mole of magnesium will give us 1 mole of hydrogen gas, okay? So, which means that for everyone, like I said, for every 1 of magnesium, you get 1 of hydrogen. So, meaning for the number of moles of magnesium used, the same number of moles of hydrogen will be formed. So, using the mass of magnesium, we can calculate to find the number of moles of magnesium. And those number of moles of magnesium, they will be the same as the number of moles of hydrogen. We use the equation N is equal to M over M, that is small m over capital M, right? The mass that you are going to use is the 1.5 grams that's given. The molar mass of magnesium, it's 24, you can get that on your periodic table, okay? Compute that, and you get 0.0625 moles. We mentioned that the molar ratio tells us that for every 1 of magnesium, we get 1 of hydrogen. So this tells us, listen, this tells us that the number of moles of hydrogen gas is 0.0625. Now we have the number of moles of hydrogen gas. We have the molar mass of hydrogen gas. We can easily find the mass. How do we do that? We also rearrange this equation, n is equal to small m over capital M. And then the mass will be equal to the product of your number of moles multiplied by your molar mass. Okay? So now your number of moles of hydrogen gas is 0.0625. Multiply that by the molar mass of your hydrogen. Hydrogen has an atomic weight of 1. But then remember that hydrogen gas is composed of, the hydrogen molecule is composed of 2 hydrogen atoms. So the molar mass of hydrogen will be 2 times the atomic weight of hydrogen. Compute that, and then the final mass that you get, the mass of hydrogen, will be 0.125 grams.